This is going to be a short video to recap some of the work we did in class talking about probability trees. So we're going to talk about an event of flying a flight mission. So we have 3 pilots, Adam, Brad, and Kathy, A, B, and C, and they're going to each go on a mission, and the probability of success on their mission is 80%. So success, we're going to say, is the probability of them hitting a target, and the failure would be the probability of them not hitting the target, or probability of missing. We're only going to be interested in hitting at the moment. Some things we want to keep in mind. These are going to be independent events. Independent. Because what Adam does not affect what Brad or Kathy do, or if Brad is successful, it doesn't matter to Adam or Kathy's mission. So we're going to start. We're going to have Adam go on his mission, and we have 2 possibilities. Adam can be successful, so that would be the probability of hitting the target, or we can have the probability of missing the target. So the probability of being successful or hitting is 0.8. Since there is only 2 possibilities, the probability of missing has to be 0.2 or 20%. So I'm going to call this A here, because this set is going to be Adam can either hit or miss. Now we're going to send Brad on his mission. So when Brad goes out, he can hit or miss. But we're going to branch it off this, because first we're going to say, well, what if Adam hit? Well, Brad can now hit, and he'll do so at 80% of the time, or Brad can miss. So probability of missing here is 20%. It makes no difference what this is. It's still an 80% success rate and 20% failure. So this is for Brad now. And if Adam misses, because these are independent, Brad is still going to hit 80% of the time, and the probability of missing is still going to be 20% of the time. And now we're going to move on to Kathy. And Kathy, again, doesn't care what Adam or Brad did before. So over here, we have Adam hit, Brad hit, and then Kathy could hit. That would be the probability of hitting. Or Kathy could miss, which would be the probability of missing. And again, since they're independent, this is still 0.8, and this is still 0.2. Now, if Adam hit, and then Brad missed, we still have the probability of hitting is 0.8, and the probability of missing is 0.2. And we can continue with the same idea here. Let's go out this way. The probability of hitting, 0.8. The probability of missing, 0.2. And finally, Adam and Brad both missed. Then Kathy could be the probability of hitting, still 80%, and missing is still 20%, or 0.2. So this is C in this red here. So Adam, Brad, and Kathy. So what we're focusing on now is the hits. And if we consider all the possibilities, an exhaustive list of how many hits we can get, well, Adam, Brad, and Kathy could all miss. That could happen. So that would be 0 hits. 1 of the 3 could hit. 2 of the 3 could hit. Or finally, 3 of the 3 could hit. And that's an exhaustive list of possibilities. If we go on 3 missions, then we're going to have no hits, 1 hit, 2 hits, or 3 hits. Now I want to know, what is the probability of each of these things? What is the probability of hitting 0 times? What is the probability of hitting 1? What is the probability of hitting twice? And what is the probability of hitting 3? We're going to start on each end. The probability of hitting 3 times, so the probability of getting a hit, followed by a hit, followed by a hit. Well, that's going to be the probability of getting a hit. So we're going to follow this chain here. It's going to be the probability of getting a hit here, then the probability of getting a hit, and the probability of getting a hit. So I'm just going to circle this set of branches here. And I won't do this every time because it'll just make a mess, but there's the probability of getting 3 hits. So that's going to be 0.8 for the first hit, multiplied by 0.8 for the second hit, multiplied by 0.8 for the third hit. No other set of branches gives us 3 hits. So this is the only way to get all 3. We multiply those together, we get 0.512. So the probability of getting 3 hits is 0.512. Now, there's 3 ways to get 2 hits. Or actually, I said I'd start on the end, so let's go to 0 hits first. So to get all misses, the probability of a miss, and a miss is this last one. And that's going to be 0.2 times 0.2 times 0.2, which is 0.008. And that's this branch here. 0.2, 0.2, and 0.2 coming down across the bottom of the tree. So that's 0.008. Now, we need to know the probability of 1 hit. So we've already accounted for the top and the bottom, and maybe I should circle this to get rid of it. That's done. We have 1, 2, 3, 4, 5, 6 other branches to consider. 3 of those are going to give us 1 hit, and 3 of those are going to give us 2 hits. So, what can happen? Well, this branch here is the probability of a hit, followed by a hit, followed by a miss. So this is hit, hit, miss. And that's going to come from 0.2, 0.8, 0.8, and 0.2. So 0.8 times 0.8 times 0.2. And we're going to learn faster ways to do this, but for the moment we'll do it this way, so that's 0.128. And we can look at this branch. Well, this is a hit, followed by a miss, followed by a hit. So that is, again, getting 2 hits. Just in a different order, but they're independent, so it doesn't matter. 0.8, 0.2, and 0.8, and you'll see it's still 0.128. And now I'm going to go to this one here, kind of in the middle, skip one. This is a miss, followed by a hit, followed by a hit. So this is a probability here of a hit, followed by a hit, followed by a miss. And I got that backwards. So let's change that around. It's going to be the probability of a miss, followed by a hit, followed by a hit. So that's going to be 0.2, 0.8, and 0.8. And we multiply all those together, again, 1.28. So the probability of 2 hits is going to be the sum of all 3 of those. So 128 plus 0.128 plus 0.128, and that is going to be 0. What does that give us? That's 483. So 0.384. So all we have to do left to do then is what is the probability of getting 1 hit? And I'm going to do a little trick on the side, and then we'll show that it's the same. We can use the complement for that. So remember, the complement is kind of like the opposite. If I want to know the probability of 1 hit, then I can say that's the same as 1 minus the probability of any other options. So in this case, that would be the probability of 1 minus the probability of 0, 2, or 3. So the probability of 1 hit is going to equal 1 minus 0.008 plus 0.384 plus 0.512, because that's all the other options. So if we add those together and subtract from 1, that's going to give us the probability of 1 hit. And so we'll get that answer in a second. The other way to do it, of course, is just like we did here. Look at our branches. So if I'm interested now in the probability of one hit, so I can hit, miss, miss, that's in here. Hit, miss, miss. That's going to give us 0.8 times 0.2 times 0.2. 822, which is 0.032. And we can have miss, hit, miss on this branch. And hopefully you're seeing now that that's going to be the same. And this last one is miss, miss, hit. And again, 0.032. We add those together, we get 0.096. Hopefully you did this over here, you saw it was exactly the same. Because that's just a different way to find the same calculation. So you can see how we can use the tree to give us all kinds of different probabilities. I'm just going to do 2 quick questions based on this tree before we end here. Based on all this information, we can find out some interesting stuff. For example, what is the probability of getting, well, 2 is a silly question because we already have it written there. What is the probability of, well, let's ask it a different way, having greater than 2 hits? So we think about it. Greater than 2 means we have to have 3. So that has to be the same as the probability of 3. That one's pretty straightforward. The probability of at least 1. So at least 1 means bigger than or equal to 1. So that would be the probability of getting 1 hit plus the probability of getting 2 hits plus the probability of getting 3 hits. Or that could be the probability of 1 minus the probability of getting no hits. This would be the complement again. Either way, you get 0.992 as the probability of getting at least 1 or greater than or equal to 1 hit. And let's see if we can do another example. Let's say, what is the probability of getting less than or equal to 1 hit? And just so you're aware, less than or equal to 1 is the same as the probability of getting less than 2. Because less than or equal to 1 is 0 and 1, less than 2 is 0 and 1. So those are the same question. So to do that, we need the probability of no hits plus the probability of 1 hit. And if we add those together, we should see that that's 0.104. And we can ask you lots of different questions about that. We can ask you what's the probability of getting 1 or 3 hits. So that would be the sum of just 1 and 3. So that's a quick recap of a probability tree. Hopefully you can follow along with that example. It's certainly an example that we're going to return to in some future lessons.